Hello everybody, and welcome back. In today's video, I'm going to go over the design iterations of my 1-pound combat robot, Death by 1001 Cuts. We'll take a look at its origins, all the way to its current configuration, and where I plan to take the design in the future. So let's get started. This is what remains of Death by 1000 Cuts, the first combat robot that I ever created. At the time I built this, I was attending my local community college and had access to an industrial 3D printer and a full machine shop. The robot was 3D printed out of ABS plastic, and the top and the bottom covers were actually made out of laser cut Xbox DVD cases, which gave it this cool green color. There's a aluminum spine that goes front to back, which had the weapon motor connected to it, and then I have a scrap piece of stainless steel which I used as my weapon bar. And if you see these two little holes, I mounted the bar directly to a weapon motor, and I used baling wire. This is the best way that I could come up with the limited time. I built this in a couple of weeks before the event, and I was pretty short on weight, and I'd never really seen how these had come together, and so that's what I did. Did it work well? No, not really. It kind of came apart pretty much every time I used it, but it was definitely pretty cool. It would ping pong around the arena, and the crowd loved it. So anyways, moving on to the drive, I used Banebot's green wheels that were 1 3/8" diameter, 400 thousandths wide, 4 of them with 16 GA motors, and I used BotBit's 10 amp ESCs. This predates the NBOT's DESC by probably a year and a half, 2 years, so this one did not use that. I did quite well in this event. I took 3rd place. And before I talk about what lessons I learned, let's take a brief look at 2 of my matches from the event. This match was against a tank tread robot called Buzzsaw. At the start of the match, we trade a few hits, which damages his frame enough to the point at which he can no longer spin. We dance around for a bit while I try and get good bite on a spot. Because of my tip speed and blade shape, I don't get much, if any, bite. Despite not causing much damage, I was still in control of most of my matches due to a 4-wheel drive design. This allowed me to outpush opponents handily. When the pit opened, I was in the perfect spot to deposit Buzzsaw into the pit, and so I did. Buzzsaw went on to take 2nd place after defeating me in a rematch. Now let's take a look at where this damage came from. This robot, Guildenstern, swept the competition with its heavy vertical bar spinner. I knew this was going to be a rough match. My only hope was lasting long enough to get him into the pit. Unfortunately, this did not happen. Guildenstern tore a bunch of parts off my robot, breaking every frame connection point and tearing off my top cover, which exposed my battery. One of the 4 motors took a direct hit, shattering the gearbox, but still, it kept going. Over and over, I fed myself into the maw, each time sustaining more damage. Everyone thought I would tap out, but I had, and still have, the mindset that as long as I can move, I will not tap out. Guildenstern's driver slowed down a bit to give me the opportunity, but I did not take it. Once I started pushing him, he again resumed his attack, and finally, he got a direct hit on my power switch, which disabled my robot. The crowd went nuts, and that secured Death by 1000 Cuts' place in the history books. At least in our local scene. But what did I learn from this design? First off, I knew that I needed a better way of attaching the blade, as well as some form of reduction. I also learned that 3D printing, at least at the time, was not suitable for combat, and that I should investigate metal designs. And lastly, I learned that I enjoyed the extra power provided by 4-wheel drive, and that driving practice was key. Before we get into the next design iteration, if you enjoy this type of content, please take a moment to click like and subscribe. It really helps small channels like mine grow. This brings us to our second version. This version brought forth a lot of design changes. I replaced the stainless steel weapon bar with a 1/16 inch thick, 6 inch diameter titanium bow tie shaped blade. I machined the shaft to hold the blade and used an O-ring to reduce the RPM of the motor. The frame is now made of 6061 aluminum and has integral wheel guards. I replaced the GA16 motors with N20 motors that are 30-to-1 ratio, and the drive motors were installed in plastic mounts that I purchased off of SparkFun's website. I also machined my own wheels and wheel molds and cast polyurethane rubber wheels. These held up great and have been used on all future versions of Death by 1001 Cuts. If this video gets 500 likes, I'll make a video detailing how you can cast your own wheels. So go ahead and smash that like button. I went a little over my weight budget, so I had to make some changes to make weight. And the first is I drilled this triangular pattern into the top cover. And the second thing that I did is I replaced the screws that hold the top cover with nylon ones. And you might be wondering, was that a good idea? Did it work real well? The answer, of course, is no. It worked terribly. I broke a whole bunch of them, and I was just lucky enough that I had enough to get through the event. The only time that all 4 screws broke was during the rumble, which caused the battery to fall out again. 1001 Cuts did very well, reliably outdriving or knocking out its opponents. Sadly, there's almost no footage from this event, other than the best hits video, of which I pulled these clips. I was narrowly able to secure a first place finish against Cybar when he started having intermittent power issues. This allowed me to deposit him in the pit. Despite taking very little damage, I knew that I needed to make a few changes, and that brings us to our third revision. This version used a different weapon motor, which was very underpowered. It only competed in Mega Mayhem at 2014, and it took 3rd place against a field of fairly decent bots. The frame is more compact, and I reduced the diameter of the blade to 5 inches, while increasing the thickness to 100 thousandths of an inch. I cut out several different weapon designs and finally settled on 2 different ones, a single tooth bow tie blade and a regular bow tie blade, which is shown here. I replaced the heavy plastic motor mounts with integral mounts machined directly into the frame. This system works quite well, and is now how I do all of my N20 motor mounts. The mount allows for a little bit of movement, which helps to absorb impacts. I spent most of my matches pushing, as I had issues with losing the O-rings on the weapon. Drive also had intermittent problems with a couple of the gearboxes, which is very frustrating as it affected drivability. After the event, I decided to move on to Revision 4 and return to the original weapon motor. On this design, I switched back to the original weapon motor and swapped the bar to a single-tooth disc, which works amazingly well. I replaced the drill bushing, which I had been using, with an oil light, and removed the stator from the weapon motor and pressed it directly into the frame. The reason that I did this was to reduce the height of the motor. I also swapped out the Tired BotBits 10 amp ESCs for the new DESC. This gave me weight savings over any other available options. Because the DESC's success in 1001 Cuts, I went on to Found Bots and start providing them to builders. There's a link below to the DESC if you'd like to purchase your own. I also had a bent titanium wedge, which could either go on the front or back of the robot, depending on the opponent. With these modifications, Death by 1001 Cuts went on to win CERC 2015. There were a few hiccups along the way. The reoccurring problem of losing the O-ring had kept rearing its ugly head. In 2016, I decided to try something radical and made my own motor bell with a gear cut into it so that would prevent the weapon from stopping. Except it overheated and stripped out the gear teeth. After 2016, I decided to take a break from the design. So what are my plans for the design moving forward? I actually machined revision 5, but I ended up deciding that I didn't like this after I machined it. It was going to have 2 motors instead of 4. And I think that there would have been more complications and issues with that than I would have liked. And I ultimately decided to scrap this. I mean, I kept the frame around, but I don't think I'm ever going to build it out. Since I built the original ones, motor technology has improved dramatically due to the quadcopter market. And I found these. This motor is very, very powerful. It's probably 2 to 3 times more powerful than the original motor that I used. And I think that I'm going to use this for my new version. Obviously, I'll have to cut the shaft off, and just the magnets are crazy on this thing. So what I'm going to do is I'm going to remove this and press it in, and then there'll be a pocket on the bottom, like on this one, for the bearing. So I'll push the bearing in on one side, push the stator in on the other side, and then this will drop down and fasten directly to the motor, same way as on the other ones. I think that worked really well. It is a little bit critical on tolerances, but nothing that I can't manage. And then on top, I'm going to fasten a belt. I'm going to go to a timing belt instead of a O-ring, because I eventually did figure out why I was going through O-rings like crazy. And what it was is that when the bar was spinning, it would pull. So if I'm spinning this way, this side of the belt would be tight, and this side of the belt would be loose. And then when I had an impact, what had happened is the O-ring would snap, or it would deform to the point where it would come apart. I don't think that I'm going to do gears again. This actually, the profile that I used isn't a gear, it's actually a sprocket. But I wanted to be able to machine it from one point, so I machined this whole thing. You can see the tool marks are still in it. Obviously that idea didn't work. I got a whole bunch of funny faces from it, and a lot of people were like, I can't believe you did that. And well, I wanted to try something different, and it did actually, in testing, it worked great. But well, once things started to heat up, it was over. You can see that those are all pulled out of shape. Kind of gives you the idea of the forces at play. This is 6061 aluminum. So anyways, I do have a couple of concept drawings that I've done. I do like the idea of having a wedge on the front. That will allow me to push. I'm gonna get rid of the bump that's on the front, just like this one, because what happens with the bump is that I have to push from here or here, and then it tends to make me want to turn when I push, because this kind of turns into a pivoting point. So by having something like this and then having an angled wedge on the front, that so this will be in there like that, and then there'll be a wedge on the front, so there won't be too much sticking out, but that will allow me to push opponents better, whether the blade's spinning or not, and that'll give me a lot more control of my opponents. Anyways, this video is getting kind of long, so I think I'm going to cut it short here. And if you enjoy this type of content, please like and subscribe. And thank you for watching.